Daily one case study from Academic Heights. Learn from home. Why Academic Heights? Clarity in understanding. Crystal clear concepts. You will get it. We cover basics and core concepts. Indirectly, you prepare for your future competency. Your learning point starts here. I am ready to teach you. Are you ready to learn? So, case study questions for class 10th. Today we'll see the case study question on one of the question on library. So chapter 1, real numbers. So better you have to read this question carefully. After that, based on this theme, we have to answer the case study question. To enhance the reading skills of grade 10 students, the school nominates you and two of your friends to set up a class library. There are two sections, section A and section B of grade 10th. There are 32 students in section A and 36 students in section B. So indirectly, this is the case study question based on library. We have to set up a library with the help of your two friends. So who are visiting to your library? So section A and section B students, they are visiting to library. Section A of 32 students and section B of 36 students, they are visiting to library. So based on this data, let's find out what are the questions we have in this case study. What is the minimum number of books you will acquire for the class library so that they can distribute equally among of section A and section B? So some keywords are there here. This will really help us to do that problem. So minimum number, it indicates indirectly, that is LCM. We have to find the LCM of the two numbers. Section A, how many students we have? In the data he has given 32 students. In section B, how many students we have? So earlier data he has given 36 students. So indirectly he is asking LCM of 32 and once again, just to read the question, you will come to understood this. Why only LCM? Why not HCF? What is the minimum number of books you will be acquired for the class library so that they can be distributed equally among the section A or section B? So here he has given the options. So here we have to select one of the number. We have to select the one of the number that should be divided with 32 as well as 36. We have to select one of the number that will divides with 32 as well as 36. Indirectly, we have to find the LCM of this. So how to find the LCM? So we have many methods. So we'll adopt here prime factoration method. So based on prime factoration method, we'll find the LCM. So first 32 prime factors you have to find. 32. What are the prime factors for 32? Product of prime factors. So 2 table, 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are. So this 32, I can write it as 2 to the power of 5. So why 5? So how many 2's we have? 2 into 2 into 2 into 2 into 2. So 2 to the power of 5. Similarly, I want to write 36 as product of prime factors. So 2 18s are 36, 2 9s are 18, 3 3s are 9, 3 1s are. So this 36 number, we can write it as 2 to the power of 2 into 3 to the power of 2. So we have 2 2's and 3 2's. We have so 2 square and 3 square. So this is the way of writing the product of prime factors. Already you have learned in the previous classes. So let's we find out LCM. How to find the LCM? How to find the LCM? Question yourself. We have to take greatest power of each and every prime number involved in that. Once again, greatest power of each prime number involved in the numbers. So find the LCM. LCM of 32 and 36. What is the greatest power of 2 here? Among these two, which is the greatest power? 2 power 2 or 2 power 5? Easily we can identify 2 power 5 is the greatest. We consider that one. 3 to the power of 2, and we don't have here any 3 terms. I can write this one is 3 to the power of 0. Yes, I can write 3 to the power of 0 is 1. So what is the greatest power? We have to take it. The greatest power of 3. That is nothing but 3 square. So your LCM is 2 to the power of 5 into 3 square. So already 2 to the power of 5 value. 2 to the power of 5 value is how much? 35. 32. 32 into 9. 3 square is 3 into 3, that is 9. So 32 into 9, multiply it. 9 2s are 18. 9 3s are 27. 27 plus 1. 27 plus 1. 288. 288. C option is here. So your option for this question is C. C is your option for this question. So I hope you understood why we have taken only LCM. Why? Because of some keywords they will indirectly states that you have to find the LCM for this problem. Coming to the next question. If the product of two positive integers is equal to product of HCF and LCM is true, then HCF of 32 36 is HCF of 32 36 is if the product of two positive integers is equal to product of their HCF and LCM is true, then what is HCF? Indirectly he is asking A into B, product of two numbers, is equal to their LCM into their HCF. In this already you know these two numbers. What are the two numbers in this question? We have 32 and what is B? 36. This is section A students, we have 32. Section B students, we have 36 is equal to, just now we got the answer of LCM. If I go back, what is the LCM? We got it as 288. So this is interdependent question. So LCM already we found out, so no need to find again. So 288, and we have to find out the HCF. So HCF is equal to, so take to that side, so 32 into 36 by 288. So cut it with 36 table, 36 ones are, and it goes by how many times? 8 ja, yes, 8 ja. So cross check it is 36 into 8, 8 4s are 8 6 are 48, 8 3s are 24, 24 plus 4 28. So it goes by 8 times. 36 ones are 36 8. Again I can cut it, in this way. So 8 ones are 8 4s are. So therefore what I got HCF HCF is equal to 4 here. HCF is equal to 4. So among these options, which is the correct option here? 4 is the correct option. So in this question, I have used, based on the question, I have used this formula. So product of two positive integers is equal to product of HCF and LCM. So based on this, we got it. The same question we can do by in other method also. So what is the other method we have? So let us see this other method. What is the other method? So I am taking this one, 32. Can change the. So this is 32. Just now 32 we have expressed it as 2 to the power of 5. 32 we expressed it as 2 to the power of 36. We expressed it as 2 to the power of 2 into 3 to the power of. Just to go back and check it. 32 what we wrote? 2 power 5 and 3 power 0. 36 we wrote it as 2 power 2 and 3 square. So same thing I wrote it here. Same thing I wrote it here. So find the HCF. Find the HCF of 32 and 36. So what is HCF? We have to consider lowest power of common prime factor. So we have a common prime factor 2 is here in the both the numbers. We have to take the lowest power of that one. It's not highest power, lowest power. So in 2 power 5 and 2 power 2, what is the lowest power? 2 to the power of 2, we have lowest power. Into what is the lowest power among these two numbers? Is the 3 power 0 or 3 power 2? We have 3 power 0. So ultimately what we are getting? 2 square, 2 2s are 4, 4 into. So we can do by this method also, and if not based on the question, we can do by this method. So whichever method is easy for you, you can adopt that one and go for and practice it. Next question. Third question. 36 can be expressed as the product of prime as. 36 can be expressed as a product of its prime as. Already we wrote this question, the first part. See, this first part we have used nearly 2 times. The first part, whatever we have, 36. So 36 I have factorized in this way here. So 2 18s are 36. Next 2 9s are 18, 3 3s are 9, and 3 1s are 3. So we already factorized this one. Already we know this answer. So directly we can get it. So go back. So 36 can be written as 2 to the power of 2 and 3 to the power of 2. So refer to the first question. So already we have done. So directly we can select the option. What is the option here? A option. So option A. I hope you understood. Just go to the first question. How we done? This is interrelated to the first question. Next one. So 7 into 11 into 13 into 15 plus 15 is a prime factor, composite number, neither prime nor composite, none of the above. So what is the number neither prime nor composite? We have only one number, that is 1. 1 is not belongs to prime number and not belongs to composite number. So what is a prime number? You know from small classes, from lower classes onwards, you about these prime numbers, you know very good concept. So what is prime number? It should have only two factors. One and itself. What is itself? If the number is 2, that is 2. If number is 3, that is 3. If number is 5, that is 5. 1 and itself. That is a prime number. Only two factors you have. So what is composite number? Composite number will have more than two factors. More than two factors. So based on this, we can easily recognize that the given number is a prime number or composite number, or neither prime nor composite, or none of the above. We'll identify this one. So here, if you keenly observe, we have only two terms. So here up to here we have only one term. This is one term. This is one more term. We have only two terms. In the given numeric expression, we have only two terms. In these two terms, I am easily identifying 15 is common in the both the terms. So this is very, very important. 15 is available in the both the terms. First of all, I have two terms. In these two terms, 15 is available in the two terms. So I will take 15 common. I'm taking 15 common. So if I take 15 common, what is left out? This is product is left out to you. 7 into 11 into 13 plus, and 15 is gone. I can write 15 into 1. If 15 take out from this term, what is left out? 1 is left out. 1 I can write it. This is 1. So many children, when we take 15, they will write different answer here. They will write something 0, they will write something other than that. So be careful. To take 15 common, you should write the total term is gone. Indirectly, what is there? That place we have 1 is there. 15 can be written as 15 into 1. The font will be available there. So 15 into no need of calculator this number. 15 into this number. So 7 into 11 into 13. 11 into 13 plus 1. Now, what is this one? A into B. This is in the form of A into B. For A into B number, we have already 1 is a factor. 1 is always factor for any number. For AB, the product of AB, 1 is always a factor. So for AB, A is always a factor. Why? Because of in A into B, we have A is available. So A is also a factor. So B is also a factor. So how many factors we got it? 1, 2, 3. It is more than 2. Is the factors is greater than 2 factors we are getting. So indirectly, what is greater than 2? It is nothing but a composite. Your option is B. Simple. For A into B number, what are the factors we have? What are the different factors we have? It is clearly we are getting 1 as a factor. By default, 1 is a factor for every number. In A into B, A is already there available. So A should be a factor. And in A into B, B is also there. B should be a factor. And AB is also a factor. For AB, AB is also a factor. So we are getting more than 2 factors. So your option is B, composite number. So let's complete the last sum. If P and Q are positive integers such that P is AB square and Q is A square B, where A, B are prime numbers, then the LCM of PQ is. So as it is the first question he is asking. In the first question, how we got the LCM? We have taken greatest power of each prime factor involved in that. We can apply it here also. So P is equal to AB square, Q is equal to A square B. So LCM, what is LCM? The LCM of PQ is the highest power of prime number involved in this. So in A power 1, A power 2, what is the highest power? How to take A power 2 into. In B square and B power 1, what is the highest power? Square, the highest power. So what is the LCM here? A square into B square. So A square into B. So this is your option is. So that's all from my side. So this is daily one case study from academic heights. I am ready to teach you. Are you ready to learn?